Hi, this is a video covering updates to the WT-220, my clever serial terminal, a homage to the WT-220. So the main updates to this rear panel here, designed a custom PCB. So the PCB is now both the mechanical rear panel and also the electronic panel, so it includes a microcontroller, the RS-232 level shifter, new addition of a USB-C and controller, USB ports via a panel mount connector, some buffered I/O, 0 to 10 volt our input, 0 to 5 volt output, and some open collector outputs. Yeah, you can also switch the UART or RS-232 to different devices, so the microcontroller or the Raspberry Pi. Yeah, I decided to redesign the rear panel. Previously it was just an acrylic laser cut piece with panel mount connectors screwed in and then soldered to various places, bits of breadboard. But I sort of dreaded taking the panel out because it was a real pain to reconnect everything, or you might not connect things correctly. The other problem was I had a power supply buck converter supply with a DC jack to get the current required for the Raspberry Pi 3 and the screen, which is in here, which is about 3 amps you need. Same with the micro B connector. It's always a pain trying to get power supply of the right power capability. So that's why I added the USB-C connector. Turns out great minds think alike, because now the Raspberry Pi 4 has got one as well. Yeah, if I show you first plugging it in with the cool thing about the USB-C is I've got the a USB-C controller there to control the CC lines and do current mode detection, so see what the upstream device is capable of supplying. You can see I plugged it in. Lots of status LEDs as you need on a hobby project like this, but the main thing is the WT-220 chip allows you to do automatic CC line pull down configuration and detection of what the upstream device is doing and output on GPIO pins. So I've connected these GPIOs to LED indicators, and if you look on the silk, not sure if it will focus. Yeah, I think you can just about see it. It'll actually tell you what the current detection is, and with both LEDs on, it means you've got 3 amps full power delivery capability, because this is a MacBook Pro charger. It's 80 watts. Normally it will power a MacBook Pro battery pack, I think it's 24 or 20 volts, so it's no problem. 5 volts, 3 amps, 15 watts. But yeah, if I unplug that and plug in, for example, just straight from my Mac USB port, an old one, which is only 500 milliamp standard USB, you see only one LED is on, and if you looked at the silk, it would actually be just a 500 milliamp detection. So you wouldn't want to turn it on in this case with the boot button. So I've got a little boot button here to enable the Raspberry Pi power supply. It's part of what the microcontroller SAMD is doing. Yeah, I mean, with this chip, what's cool is it communicates over I2C, so you could actually limit the use of this button, but for my use I'm just using the LEDs to visually limit. You require the user to understand what's going on, but for a consumer device it's quite a handy feature. You could stop someone turning it on if the power supply is detected to be inadequate, so they don't think the thing's broken. But yeah, if you plug in the suitable supply again, get both LEDs on, the blink LED is just showing that the SAMD is turned on, so then this green one is a 3v3 line. These are just RX, TX LED statuses. So to turn on the Raspberry Pi, press the button, does a nice little fade to show it's booting up. If I then rotate the screen around, you see it should start booting up. You see the ASCII boot animation created. Yeah, Raspberry Pi B+, sorry, in here, so reasonably fast to boot up. It launches i3 window manager because it's meant to be a keyboard based terminal, and then once it's booted up, if you go back around here, the LED goes steady to indicate the Pi's on, and it does that by receiving a booted status over I2C from the Pi. So the SAMD always knows when the Raspberry Pi is on and when it isn't. They'll carry on linked together via a systemd service running in the background. And then yeah, we've got cool retro term booted here with the Tmux session, so you can create another panel. There you go. Went for a Bluetooth keyboard with this edition. Open HTOP. Make that zoomed. Open some cool, look like a hacker, doing nice colourful retro term stuff. And then of course, because it's running i3, I can just go to another window. Start like a Chromium browser or something with D menu. Yeah, there you go. And then I've even got this touchscreen connected, so you can scroll. But and then of course you got serial for the RS-232, and these case LEDs, they're still working as activity indicators. So if I press, change it to a really slow, like 500 bits per second baud rate, you can see the TX LED flashing. The keys have got nothing connected, so no RX, but yeah, close that. And then if I shut down, so there's a few services running in the background. One of them is maintaining I2C communication with the Pi, so it will detect if you request a shutdown. But if I request it shut down, so hold down the button, the LED will start blinking to show a shutdown's been requested, and the Pi, the service in the background, will detect that shutdown request and then shut down the system, Linux system, and then tell the SAMD to turn off at the last systemd target. So when the system's completely turned off, all the services, everything's safe to turn off the power, the SAMD will then turn off via the MOSFET switch, the 5-volt line. So now the LED's blinking just to show it's only the SAMD, and the Pi's off, and the screen's off. The LED case lights stay on just to show that the power's on.